Number Theoretic Functions Part 2. Sigma and tau are multiplicative. Welcome back to this two-part series on number theoretic functions. Here we discuss the concept of a multiplicative function and show that sigma and tau are multiplicative. A multiplicative function f is defined to be 1 such that whenever m and n are co-prime to each other, then f of mn equals f of m into f of n. With this definition, the proof that tau and sigma are multiplicative is easy. Recall that if n equals p1 to the k1, p2 to the k2 and so on all the way up to pr to the kr, then tau of n equals k1 plus 1 multiplied by k2 plus 1 all the way up to kr plus 1. Let m equal q1 to the j1, q2 to the j2 and so on all the way up to qs to the js, and let n have the same prime factorization as before. As m and n are co-prime, none of the pi's and qj's are equal to each other. Hence mn equals q1 to the j1, q2 to the j2 and so on all the way up to qs to the js multiplied by p1 to the k1, p2 to the k2 and so on all the way up to pr to the kr. Thus tau of mn equals j1 plus 1 into j2 plus 1 all the way up to js plus 1 multiplied by k1 plus 1 into k2 plus 1 all the way up to kr plus 1. But tau of m equals j1 plus 1 into j2 plus 1 all the way up to js plus 1, whence tau of mn equals tau of m into tau of n, and we are done. If either m or n are 1, we simply take all the exponents in the prime factorization to be 0. Now for sigma, we use the same notation as before. Recall that sigma of n equals p1 to the k1 plus 1 minus 1 upon p1 minus 1 multiplied by p2 to the k2 plus 1 minus 1 upon p2 minus 1 all the way up to pr to the kr plus 1 minus 1 upon pr minus 1. Again, sigma of mn equals q1 to the j1 plus 1 minus 1 upon q1 minus 1 into q2 to the j2 plus 1 minus 1 upon q2 minus 1 all the way up to qs to the js plus 1 minus 1 upon qs minus 1 multiplied by p1 to the k1 plus 1 minus 1 upon p1 minus 1 into p2 to the k2 plus 1 minus 1 upon p2 minus 1 all the way up to pr to the kr plus 1 minus 1 upon pr minus 1. Thus sigma of mn equals sigma of m into sigma of n, and we are done. Thank you for watching. The credit for the theory and the proofs goes to David M. Burton, who is the author of the book Elementary Number Theory. Credit is also given to McGraw-Hill Education India Private Limited, who have published the Indian edition. In part 3, we discussed the concept of summing a number theoretic function little f over the divisors of n.